So thank you for that. And I think unless there's some burning question, given in the interest of time, I think we will go into our panel now. Basically what I'm going to do is call back all the speakers. There are all 7, I guess, so that we can sort of have a broad discussion of all topics. There's a lot of overlap, so it just makes sense to have everybody come on. So if everybody, as I say, all speakers can turn on their cameras, that would be awesome. And we have about 30 minutes for this part for the discussion, and then there will be a wrap up yeah, as I say, 30 minutes. So this is great. Okay, so I have a number of questions that have come in. I think what I will do is I will start with our fearless leader, Dr. Corsi. You had a question that you wanted to kick us off with?
Yeah, thank you, Kim. So Andrea, I appreciate that you discussed disparities and socioeconomic impacts towards the end of your presentation. I'm wondering if all of the last 4 speakers, Nina, you spoke about cooking, and Lindsay about humidity control, or the impacts of humidity and potential impacts of humidity control. Michael, you talked about precursors to ozone chemistry. Can you maybe put that in the context of, again, possible disparities in underserved communities, those that don't have the economic resources or even the systems in their own homes to deal with those things? Start with Nina and cooking.
Okay, yeah, I can go first. I think I don't even know how much more to add there. I think the issue of socioeconomic disparities is important. It's a huge knowledge gap. We don't really know much about what to do to reduce exposure in terms of indoor cooking emissions for those who are economically disadvantaged. Because in my last slide, I mentioned, the easiest way to cut down on your exposure to cooking emissions is to reduce exposure at the source. So operate your well-running externally venting hood or having a portable air cleaner. If you're renting a house, you are going to have what you have, right? You're not going to make that massive investment on an externally vented hood. You may or may not be able to make the investment on a portable air cleaner. There may be other issues that are far more important to you, like cooking that food itself and putting that food on the table rather than, mitigating the indoor emissions from the food. I think this, in the specific case of cooking, it ties into the need for modern activity patterns that Andrea just mentioned in her talk. I think it's important for us to understand what people do in their real homes, what are their actual habits when it comes to cooking activities, and how do those habits change with socioeconomic status, with culture and region in the country and in the world. And then with that knowledge, we can inform better experiments to understand those realistic exposures. The results I presented from home chem, we can't do home chem in a regular house. We parked 4 trailers outside of a test house, but we could do an experiment like that, better informed by the reality that people have in their own homes.
Somebody else want to chime in on this?
Sure, I can talk for a minute. So for SOA, I think it kind of comes down to 3 issues I was just brainstorming. It's like, are there differences in outdoor concentrations for underserved communities, or are they in regions of higher ozone and organic or inorganic particulate matter concentrations, which can infiltrate and potentially drive secondary chemistry? Are there differences in emissions of particular VOCs or precursors in housing types in underserved communities versus not? Is there a different VOC mix depending on potentially the quality of the housing or the type of construction of the housing? And then I think even less well known is maybe, are there different types of products used for people in different socioeconomic status? And this I know less about, But our particular consumer products that are consumed by various groups, leading more to precursors inside than maybe other precursors in different types of consumer products that are potentially marketed, for instance, to more affluent people or something like that. So I think putting all those three things together, you can maybe start to tease out a picture of disparities in SOA exposure amongst underserved communities or poorer communities. I haven't done this, but I would think that that would be where you would start to break this down at.
I can answer this. I recently began collaborating with a colleague, Freddie Page, who works with underserved communities, looking at energy savings in buildings, and we're talking about indoor environmental quality. And they are not concerned about ozone or VOCs, or including phthalates or plasticizers. Their number one concern is mold, because it's, they see asthma and allergy, major asthma and allergy problems. And I think from what I've heard, at least, and kind of seen in the literature, I haven't looked into it deeply, this is, allergies and asthma and respiratory problems associated with mold are definitely more prominent in underserved communities. And I think it has to do with, maintenance of buildings and correcting leaks and things. But there's, I wonder if that's also part of why we see there's really fairly little literature on mold outside of study by mycologists.
Yeah, I'll just add, like, anecdotally, I was part of a project that went to New York Public Housing and took measurements in there as part of the MOBI effort that the Sloan Foundation was doing before. And the mold in the public housing was through the roof. I mean, it was everywhere. Every unit we were in had evidence of mold. Every hallway, etc. I mean, it just, I don't remember seeing a unit that did not have some sort of visible mold in it.
And that's going to.
Oh, sorry.
Go ahead.
I just wanted to mention, with exposure, we think about the concentration in the breathing zone times the time for the inhalation exposure. And for underserved communities, I don't think we've really focused on school and residential here, but the occupation would also be a big difference in exposure. There's great work being done on exposures in nail salons for workers in nail salons and cleaning and, different occupations that you would have higher exposures or different exposures.
I was going to say that was one of the questions that came in, basically pointed that out. The other example are people who are doing industrial food preparation, huge emissions, they're going to get massive exposure from that as well. So yeah, did anybody else want to chime in on that question? Because if not, we'll. Okay. I see a hand up, and I'm kind of juggling multiple. Okay, let's Elizabeth, you jumped on and your hand's up, so let's go with you with the question now.
Yes, so it's really related to this discussion about disparities that also shifted a little bit to the biologic sort of compartment or compositional piece of PM 2.5. And what I wonder is yeah, I'm an allergist, so my work has focused on measuring indoor allergens. And when we've looked at indoor allergen exposure in susceptible populations and health effects compared to indoor PM 2.5, the health effects of PM 2.5 are clearly there, but they are smaller consistently and not by a small amount than some of these biologic contributors. And these include pest allergens, which relate to, of course, the disparities discussion we're having. I think what Lindsay brought up is, related to mold, is a concern, obviously, of disadvantaged communities, but also there's literature, that really bears out that there are substantial health effects. So how do we marry, the biologic components that are broader than, thinking about, transmission of infectious agents, and are incredibly variable with sort of thinking about other indoor sources, thinking about indoor chemistry, thinking about humidity, and so on and so forth. And there's also an intersection because when you have animals in the home, of course, they introduce microbes. We know, as one example, endotoxin concentrations in the air in homes is correlated with mouse allergen levels in the air. So we have yet another sort of intersection going on there. So this feels large to wrap my brain around in terms of thinking about the implications for mitigation. And I'm also not a chemist, so this also strikes me as very complicated from a chemistry standpoint. And this question may actually, be for anybody who just spoke, who has given some thought to this issue.
I can speak to this because I've been studying viruses in the indoor environment for a long time. And I think the mold question is another one that falls in this kind of interagency hole. NIH, it's not inside the body, so they don't care. NSF, well, that's health related, so they don't care. With EPA, it's like, oh, maybe kind of, but that's my view. But one of the reasons that some of which others we've already discussed of why some of these topics have kind of not received as much attention as the magnitude of health effects would suggest that they deserve.
It sounds like a call for maybe some cross-agency initiative. I don't want to put words in your mouth, but
I'm happy to voice that too. I think that one of the challenges that your question highlights is the fact that there are so many different factors that are potentially influencing indoor air quality and health and indoor environments that it seems like a very complex puzzle. And there are a few very obvious threads, like airborne viruses very definitely have obvious impacts on human health, but some of these other factors we're just beginning to learn about. And understanding each of them individually, there's a strong need, but also to see how they start to interact. And I actually think the microbial VOC question is a really interesting one from that linkage to both relative humidity, but also to chemistry. And so I think the need, there's a really clear need, and I think all of the talks highlighted that from my perspective, to not only think about this complex indoor air environment and what we can do to improve it, particularly in underserved communities, but also the need to start having cross-disciplinary discussions, because there's it's such a complex problem that it can't be tackled by just a chemist, let alone anybody else. And so I think there's a strong need to have more interdisciplinary interactions to tackle the problem as well.
I would just jump in to tack on something that's I've noticed over the years, which is just resources. So in addition to a cross-agency sort of thing, sort of priority, anytime we do field work, we end up spending half our time talking about what can we possibly measure, right? The intensity of resources that went into home chem, a bunch of measurements in one home in this whole planet, right, was really high. And so we end up doing sort of whatever your detection du jour is, right? And how can we make a kit of $8,000 that's deployable to multiple buildings or what have you? So we spend a lot of time on that, and I think we miss a lot of opportunities because of resource constraints.
Okay, does anybody else want to contribute? Sunny, did you want to comment?
Yeah, I'd like to make a comment that I think it's time for us to, I think the shock and awe about how bad things are for underserved communities, the time for that is over. We know it's happening. We know it's bad. We know it's disproportionate. And any efforts outside of trying to alleviate these pretty egregious disparities, I think we're spinning our wheels. So if we move away from, I can't believe this is happening, to this is what's happening all over systemically, we'll probably approach the solutions a little bit differently.
But can I also ask though, do you think, to me, I really struggle with this idea of thinking about communities as one group, right? There's incredible disparities or differences in how underserved communities, what their challenges are in, say, the Los Angeles area and in the Inland Empire, right, from what they are in other communities. So maybe to just ask the question to you, Sunny, is what do you think about how we should approach those differences?
Well, thank you, Delphine, for bringing that up. What I teach in one of my courses is that this is really it's a money issue. There's just less investment in the overall quality of life for people that are disproportionately exposed, and that permeates into education, residential quality of life, access to grocery stores, healthcare. It's cross-sectorial. It's just a money issue and a lack of a willingness to put resources toward making this better. I think it's a hesitancy across the board, politics, healthcare, etc.
Thank you. Okay, I think we'll move to the next question, and that will be by Seema.
Hi, thanks. My question, Dr. Ivy, your comment sort of set it up or anticipated it. So now to piggyback on your comment about really appreciated this point, systemic solutions for systemic problems. And want to ask you, but also the others on the panel, what you see as the biggest gaps in source control, source management, either policy or regulation, that if corrected would really directly address our most vulnerable populations.
Yeah, I'd like to take a stab at this question and then I'll hand it over to everyone else. It was pre-asked, so I have a few responses already keyed up. So what I identify are the two biggest gaps is the current regulations on fossil fuel extraction and combustion. If you just take a look at domestic oil and gas extraction, where the wells are, how far away they're allowed to drill from people's homes, there's a socioeconomic footprint there, and usually the burden is on Black and Brown communities. And the other thing that just came up that was shared on social media is that environmental groups are calling for methane and ethane to be removed from exemption from VOC classification. So this would allow more strict emission standards to be placed on those groups because the activities surrounding methane and ethane emission most harmful or very harmful for disproportionate groups. And yeah, and that's those are the gaps that I've identified.
Would anybody else like to follow up?
Yeah, I'd love to hear from Dr. Marr as well, because you did flag the mold, as what you see as a major, really big ticket item. It forms the complement to what Dr. Ivy just said about the fossil fuels in terms of the outdoor source penetrating in. So on the indoor source side, sounds like mold is the big one if we're looking at vulnerability. So what types of systemic solutions it was addressed in your talk, but a quick recap maybe.
Yeah, there's, I think one thing, and this is kind of, I picked up on someone's, I think a member of the public's comment in the chat, and this is true for indoor environmental quality in general, which is that we don't have any standards. And I think, Dr. Farrow mentioned this, talking about how the outdoor standards we shouldn't just take the outdoor standards and apply them indoors. But having maybe not standards, but at least some kind of benchmark so that people can have something to shoot for, some indicator. Right now, there's absolutely nothing. And someone commented in the chat that they're a mold inspector and they don't have anything to compare to. If they go in and try to do some kind of evaluation of someone's home, there's they can say, well, here's how it compares to what we've measured before, but is this good? Is this bad? There's nothing. So I think some kind of starting of guidelines at least. You have to start somewhere. That would be a good place to start.
But do you think the reason, Lindsay, for that lack of like where you start, we keep coming back to this and we're going to have a whole session on it. So, but it's just sort of what I heard about were a lot of sources, right? So you have the biological at one end, you have, I don't know how much it was, hundreds of micrograms of ultrafine particles, which I can't even do the calculation of how many that is. So you've got low, and you have dust. We haven't really talked about dust, but I've listened to other talks and they're always talking about dust being correlated with health. Like, you have to define like kind of like what is good and what is bad. And I just don't get a sense, do we know? Like, what would we link it to? Like, I guess is the question, and that could set metrics, which we're getting at next. But I guess my bigger question is just for the people, for all of you, what do we know about sort of the size composition differences? I saw a little bit on that, but I heard a lot more about PM 2.5, even though there was clear evidence that ultrafine are really important. How much do we know about that composition? I mean, I guess, I'm just curious what you all think, sort of what is the driver of the composition besides PM 2.5 mass with the composition itself of different size ranges? Do we know?
I guess I'll take a first stab. Who knows if I can answer. I think the driver is the source. And for at least from the results from my talk, I was trying to show that the really small particles, they're coming from the heat source, but they could also be coming from the food itself. For the bigger particles, as the body of work of Dr. Farrows and others, for the coarse mode, a lot of it is coming from shedding, dust resuspension, and for the mid-range, there's a lot of particles coming from outside, as Dr. Stevens mentioned in his talk with that upside down U shape. So I think we can try, if we were to establish a framework to think about how to tackle this issue of standards, we would have to start from a framework at the top. What are the sources that we need to be concerned of? What are the health effects of each of these sources? And we don't have those, in my opinion. And then after that, to determine what would be the guideline levels that people should be measuring. So I feel like we are many steps away from reaching the end point. I'll let others chime in on this.
I'm a little unclear on how basing it off of levels and concentrations from indoor perspectives would even work, right? I mean, outside we have monitoring stations. It's much more obvious how we keep track of outdoor concentrations, but indoors, I'm wondering sometimes if instead of different concentration levels, you should use knowledge of how sources work inside with target concentrations to then recommend either behaviors that people do, best practices on how to operate your buildings during high emitting behaviors or characteristics or high emitting activities, as well as, pushing it all the way down into consumer product and building product formulation, right? And so, going backwards, looking at what concentrations would be harmful inside, relaying that to emissions based on models, and then working at that end, because that's something that I think you could actually regulate eventually or set standards for that have sort of broad average impacts we know indoors without having to get into this idea of we're going to measure pollution in every building, which is not realistic, at least at this time.
I think the other side of the coin of that too is if you are going to monitor, like really, I don't think I have the ability to understand where this field is at the moment, but measures like oxidative potential or like health relevant measures, like to what extent could we just boil composition and size effects down into some biologically relevant measure? That is extremely compelling to me.
Mm-hmm. Some level of exactly.
I don't know if I entirely agree with that, though, because if we don't understand the fundamental processes and the actual, say, the drivers of the composition and the drivers of the processes that are leading to some chemistry or some size distribution that has a health effect, then we're potentially going to control the wrong thing. So I think I guess I feel like maybe that combination of understanding health effects, but it has to be done in combination with understanding those individual sources. I think if we've learned something from the outdoor air quality world, is that you actually, in order to get the solutions to be done correctly, you have to understand the processes and the effects. So I think, I guess my thought would be that we'd want to put those aspects together and understand both the sources and their impact on composition, and then the impact on health.
Yeah, no, I like that, Delphine, and it also means that you can then distill it down to chamber and test house style studies. One of the least amount of work and the most publicity I've ever gotten in my career was when we showed that 3D printers emitted particles. I mean, it was literally showing that melting plastic emits particles. Almost no scientific rigor there, but it was exciting and interesting and potentially dangerous, right? And the deal is, I still have no idea about, I mean, we're just now starting to, there's a few studies on some toxic effects of some of these, but that measure, the measures that you actually use there, it gets out of my realm of expertise. I don't even know how to sort of evaluate some of this, but that framework, then it could be kind of, quite useful to like merge field and lab potentially. Yeah.
I wanted to get back to the dust that Kim brought up. I usually talk a lot about dust, but I didn't today. But you can think about the indoor dust sort of as a long-term reservoir, and it's not perfect, right? But in some ways, a good portion of the mass that we breathe is that resuspended dust. So we are breathing it directly. In addition, it's this reservoir, although not perfect reservoir, of all the other emissions that are happening sort of, with these short-term sources indoors. So I still think there's, and there are some studies, right, where you're using dust as a surrogate for exposure. And so this is an ongoing discussion. I think it's an important one, and one that we should still continue. I do wonder about size distribution for that dust, and I brought this up last week, right? If we looked at which components are in the different sizes, is that going to be better correlated with health impacts? Since you expect to see certain components in the different sizes, and the larger particles wouldn't enter your respiratory system anyway. So yeah,
right.
So dust has good potential.
Real quick follow-up on that, because I didn't hear anybody mention carpet, the effects of carpet. It seems like that is a big factor I've seen, that I went through something personally where we had to remove carpet because the bio exposure was so high, and the only way you could get rid of it was, these were very old carpets. Nobody talked about that, but has anybody sort of looked at the differences with and without systematically on that? Because that would affect your dust and your resuspension and all that in a major way. What do we know about that?
Dana Miller at Ohio State University, ran a workshop a couple summers ago, and there's a paper that came out of that that I was involved in, and that was on looking at this effect of flooring, specifically for the biological particles. And so it's certainly, I think it's there's definitely a difference with resuspension on hard flooring versus carpet, right? And it's much easier to clean the hard flooring than the carpet. And the carpet, you would have growth of, you would also sort of have its own microbiome. So I think that, yeah, there's a lot of work there, and most of it points toward hard flooring being a much healthier choice.
All right, looks like Renji's on. And Renji, would you like to ask your question?
Yeah, thank you. I want to make a comment first, and then I'll ask my question. One comment I have is, we mentioned cross-agency collaboration. It is very difficult. I mentioned a number of agencies already, but for homes, we have agencies that are in charge of housing, and there's also building codes that are really relying on local jurisdiction. So we have within our country so many different things that we need to think about, and we'll make real changes. And then my question is, I think for schools, one of our ask from EPA is think about schools, like what sources we are concerned about. And we know that now school have a once in a lifetime opportunity to make some investment in making schools better. Yes, that's stimulus money coming from the Biden administration. Knowing what you know about sources in school, where do you think resources should be spent in order to benefit our students and teachers?
I mean, in Philadelphia, it should be installing adequate ventilation in the schools. I mean, we have so many, and just from a first order, we have so many older schools that are heated simply by radiant heating, have no air conditioning, and have no airflow at all in the spaces. And so you get these situations where, in the winter, all the windows are shut. And then in the summer, all the windows are shut, and they may have, a portable air cleaner, but you essentially have no way to clean or turn over the air for the student populations. I mean, we also have, of course, large amounts of lead and asbestos because of the age of our housing stock. But I tend to think that those things can be sequestered, and I'd really like to see resources put into providing adequate fresh air to students before anything else.
Anybody else? So I think we're right at the end of our time. And